You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, listeners. Welcome to episode 69 of the Common Descent Podcast.
Hi.
Today's episode, our topic, we're back on dinosaurs.
Yeah.
Specifically, Ankylosaurs.
Really cool dinosaurs.
The armored dinosaurs.
These are top tier dinosaurs.
These are the tank dinosaurs.
Yes, this is the tank of the dinosaurs.
These are the ones that are covered in osteoderm, like knobs and bumps and spikes and all sorts of cool stuff. As we have with other groups of animals in the past, particularly with other groups of dinosaurs, we'll talk a bunch about what makes an ankylosaur an ankylosaur, where they fit in the grand dinosaur family tree and the dinosaur timeline. We'll talk a bit about what we know about their lifestyle. What are the famous ankylosaurs? And, of course, we will spend some time talking about what is known about their famous armor and weaponry.
Absolutely.
'Cause how could you not?
I mean, seriously, it's the thing that makes them stand out.
This subject was requested, or rather inspired, by a series of requests by Mark, Josh, and Jonathan.
Thanks.
Thank you very much, but before we get to the main topic, some announcements.
Woo!
We have a Patreon.
We do.
We encourage our listeners, if they're so inclined, to support us on Patreon. You can get all sorts of cool goodies in exchange for subscribing to us and helping to support the financial needs of the podcast. One of the goodies you get is that we'll say your name.
Absolutely.
Well, thank you, live, kind of, here on the air. This time around, we are thanking Lou.
Thanks, Lou.
Thanks for joining us, Lou.
Welcome aboard.
Hey, speaking of things that Patreon helps us do,
Yeah.
we're recording this episode after returning from our return trip to DragonCon.
Absolutely, we are. And without Patreon, we wouldn't have been able to do it, really.
That is absolutely true. Patreon, you sent us to DragonCon, which was fantastic. Because
it was wonderful.
It was a great opportunity for us to catch up with old friends, make new connections, interact with a bunch of new people, grow the podcast, the listenership. Last year when we went to DragonCon in 2018, no one knew the podcast.
Yeah, we didn't get any hands or anything in any of the panels.
This year, at least a dozen people came up to us who were listeners.
We got to meet listeners. It was so good meeting. And if any of you we met are listening now, hi again. It was so great to meet you.
Hi to Rebecca and Robert and Jess and Kyle and a bunch of people whose names we didn't get. And Bo and Brittany. Especially hello to Brittany.
Yeah.
Who's one of our top patrons and came up all nonchalant like, oh yeah, I'm just one of your patrons and a listener. And then was about to walk away and I'm like, no. Hang on. You're a patron. What's your name? God. So, Brittany, it was awesome to see you. And everybody else that we saw at DragonCon. It was so much fun. We had a blast. We recorded our Paleontology Hour panel.
Yes, we did.
So, assuming that recording comes out all good, which it seems like it will.
Yeah.
Then, sometime soon, we will have that up for people to listen to.
Yeah, so keep an eye out for that.
Keep your ears open. And patrons keep supporting us, and we'll go back to DragonCon next year.
Please, because it was so much fun.
Yes. Hey, another thing that we do is side series.
Yes, we do.
Every now and then we take a little sidestep and we do a little bonus thing. And October's coming up.
It is.
Which means the return of our special Halloween-themed Speculative Evolution series.
Spookulative Evolution!
Spooky.
Yeah.
This time with an all-new theme.
Yeah.
Different from last time. Stay tuned.
An old theme rises.
To find out what it is. But I think that's enough of that.
Absolutely.
Because we got to get to the main topic.
Yes.
And that means that we have to get through the news.
Yep.
Every episode of the Common Descent Podcast, we pick some news to talk about that's related to the interests that we have and that you have and that we talk about on the podcast. So, Will.
Yeah.
Do you have some interesting news for us?
I have news about whales.
That'll do.
Okay, cool.
Cool.
So, this is a bit of news about some seeming bite marks on some whale bones.
Oh, fun. There's a lot of things that could bite a whale.
Right? Bite marks are always fun. This research specifically is by Dearly Cortez et al. In Paleontologia Electronica. The article we'll be linking to is by Jean Timmons in Gizmodo. And this is about some whale bones, specifically whale fin bones. So, within a whale fin, there are finger bones very much like our hand, just more of them. And it's what makes up their fin. It is just a flattened, skin-covered hand.
Yeah, the flipper.
The flipper.
That's where I'd bite him.
A bunch of those bones were found, only about 2 million years old. So this is fairly recent. This was a whale that was at least related to humpbacks and blue whales. It was in the Balaenopterids, but what species it was specifically, they can't tell from the few bones they have. So they're not positive which whale it was, but it's a modern filter-feeding whale, at least similar to.
Okay.
Something in that realm. This was found in the Burica Peninsula in Panama. The first marine mammal to be recorded from the Neogene period from the peninsula there.
Interesting.
Yeah. Now that's important because it can give us information about whales during that time in that area. But the reason these bones are interesting for the article is because a number of them have scratch marks on them that seem to be tooth marks. And this suggests feeding behaviors.
Ooh.
Now the obvious jump to answer is sharks, which the tooth marks seem to support.
Oh,
because on some of the bones, the marks are a lot of parallel thin lines, which are common scratches from serrated teeth, where the serrations scrape along like a cheese grater.
It'd be like if you took a steak knife, but instead of cutting straight down with it, you scraped the knife sideways.
Exactly. Like if you just scraped it along the top of a piece of butter, it would leave a pattern in the shape of the serrations. That's what they are interpreting these parallel lines as.
Ah.
So, this is some sort of feeding behavior. Now, as cool as this kind of ichthyofossil, when you find these cool behavioral trace fossils, are, they don't give us the information as to when the shark was eating the whale. So, was it eating it before the whale died? Was it eating it at the surface while the whale was bloated, or at the sea floor after it had sunk down? We can't say for sure. But evidence, or at least evidence and the evidence and the averages seem to suggest scavenging.
Right.
Because if you're leaving tooth marks on bone, that means there's not much skin to get in the way of the tooth in the bone. You have to be fairly close to the bone at that point. And so it's not likely you're taking big meaty bites, you're scraping down to the bone, which is, follows along with scavenging behavior, that this either the skin has rotted away or been chewed off by previous bites. Now, which kind of shark it was, can't be said for sure. From the bite marks, they do hesitantly say that it was probably at least 2 sharks that left these scratches.
2 different sharks?
2 individual sharks, at least.
2 different types of sharks?
Maybe.
Okay.
So it's at least 2 different sharks because of the size categories of those scratches.
Okay.
Seem to suggest 2 different sizes of feeders. What kind of shark it is, though, can't be said for certain. It absolutely could be the modern great white, because they were around by this time, and they are common feeders on whale carcasses. There's tons of awesome videos of that on YouTube. Go look it up. So it absolutely could be something like that, a big serrated toothed shark like that. But there's also lots of other serrations, or serrated teeth in the shark world. So what it was that was eating this whale, what kind of whale it was, we still don't know. But it is giving us information about whale fall or whale scavenging feeding dynamics in the Neogene, which is cool, especially for this area.
That's a good first mammal fossil to find.
Yes, they had a line in there which was, no matter how incomplete or complete the fossil, the story it tells is the important part, and this one tells a story.
Yeah.
And that's cool.
That is very cool.
Yeah.
Well, speaking of first things, My first news piece is about the first known skull of an early Australopithecus species.
Oh.
Oh, indeed. This is research by Johannes Hale Selassie et al. In Nature, and we'll link to an article in National Geographic by Michael Greshko. So, Australopithecus is a very famous genus of primates.
Yes.
Hominins. Go check out episode 18, A and B, for a discussion of our relatives in our family tree. The most famous Australopithecus species is Australopithecus afarensis, which is the species that includes the specimen called Lucy.
Yeah, the big or the little famous one.
Yeah, it's not huge. Australopithecines are the sort of stock of hominin, human relative, out of which our genus evolved.
Yeah.
So that is sort of it was Australopithecines for a while, and then our genus Homo came in. So understanding Australopithecus is real important for understanding us. But Australopithecus was around in several different species for a couple million years. And the later Australopithecine species are much better known than the earlier ones. Specifically, there are lots of skulls of younger species of Australopithecus in the 3 to 2 million year old range. But the oldest species in the group, Australopithecus anamensis, is known pretty much just from teeth and jaws.
Yeah.
No skull. Which means we don't know a lot about early skull evolution in Australopithecus, and we don't know a lot about that species.
Yeah.
Until now.
Exciting.
This study describes a recently discovered, just in 2016, almost complete skull, so cranium, the upper part of the skull, from Ethiopia that has been identified as Australopithecus anamensis, based on similarities with parts of the jaws and teeth, mostly. Which makes it not only the first complete skull of this species, but also the oldest complete skull of any Australopithecus.
Oh, wow.
Which is real cool.
That's extremely cool.
It was discovered in the remains of a river delta on a lakeshore, probably carried downstream and buried there, and dated, based on nearby volcanic ash, potassium-40 dating, to 3.8 million years old. Oldest Australopithecus skull by a little bit.
Yeah, that's a jump.
And on first glance, it fits really nicely. It follows the patterns we would expect. It has this sort of long, more protruding face like other Australopithecus species do compared to us, closer to humans. Its facial features are beefier than earlier primates, but not as beefy as later Australopithecines.
Nice.
So it fits in the nice transitional stage. But more than that, it answers a couple of mysterious questions. First one being the identity of another bone discovered back in the early 1980s that up until now no one knew what it was. This was a frontal bone, so a piece of the skull from the, forehead region.
Yes.
That for a little while people were wondering if it belonged to this species or Australopithecus afarensis, Lucy's species. But since we never had cranial material from this older species, nobody knew.
Yeah.
Now we know it's not the older species, it's the younger species, afarensis.
Oh, okay.
Which answers another question. For a long time, a lot of paleoanthropologists have suggested that anamensis, the older species, directly gave rise to afarensis, the younger species. But that mystery bone is about 100,000 years older than this new skull.
Oh, wow.
So if the mystery bone turns out to be the younger species, it means these two species overlapped in time for 100,000 years, which suggests that at the very least things were more complicated than just a straight descendant from anamensis into afarensis. And so the complications of the human family tree continue.
On par.
Yeah, pretty much what you'd expect.
Yep. That's very cool. We paleontologists typically freak out about teeth.
Yes.
And so that's typically what we get excited for, especially with mammals, because you can identify mammals with teeth pretty well. But a cranium is always kind of the next step from that.
Yeah.
Because that really gives you a lot of information, not only about more details on relation and where this might fit in, but also it can tell you a lot about the functionality of that animal. How it was actually potentially behaving. Like, cranium's kind of a big deal for that. So I like that we are slowly piecing it back together. That's an exciting piece.
Yeah, I presume that this skull will soon be used to tell us all sorts of cool things about the earliest Australopithecus species.
Yeah.
So, fun stuff to look forward to.
Absolutely. So, speaking of minor mysteries in the fossil record, this next news article deals with the age-old question of how did dromaeosaurs use the big claw on their foot?
Ah, the raptor claw.
The killing claw.
The Velociraptor Deinonychus foot claw.
Yeah, that inner toe with that big claw. We're not actually sure what they used it for. This study attempted to try to narrow down what uses would be most likely.
Tell me more.
So this is research by Peter Bishop in PureJ, and the article we're linking to is John Tennant in the PLOS blogs. So the question of how did dromaeosaurs use that big claw has been around for a long time because it's such an exaggerated feature. Like, claws on feet being used for stuff is not uncommon, but such a ridiculously large claw, like it's so much bigger than the rest of the claws on the foot, have raised lots of questions to why they put so much adaptation into this. The potential uses have been hypothesized throughout the years, from the popular kicking, slashing foot, the killing claw, to also using it to hold on to prey, jumping on, and this is what you see in art a lot of the time, where they jump onto a big prey animal, and then they use that to latch onto the side as they bite or claw into it with the upper claws. Using it to slash at the side, jumping on the side and then kicking into it, or using their body weight to drag into it is another one. These are all things that they also looked at in the study, so these are examples that they were giving it early on. Piercing a specific spot, like using it the way people have suggested saber-toothed cats might have used their sabers to precision kill a specific organ.
Ooh.
Hitting the neck. This one has been cited a lot because of the famous fighting dinosaur specimen with the Protoceratops and the Velociraptor. One of the Velociraptor's killing claws seems to be lodged in the neck of the Protoceratops.
Yeah.
Going for potentially a vein or jugular. So that's one option. Another one that's a scale down from the jumping on giant iguanodons and big herbivores is using it to pin down medium to smaller than themselves prey. Just this big gripping claw to pin the prey and then bring the mouth down to dismember it.
That always makes me think of the scene in, forgive me, Jurassic Park 3.
Yes.
Where the Velociraptor steps on the guy and then swing,
just locks it in.
Swings the claw down.
Mm-hmm.
Yeah, but for like a little lizard.
Absolutely. Intra or interspecific defense is another suggestion, that this may have been kind of cassowary claw, where I'm using it because you're in my territory or you're attacking me, and this is my thing to fend you off. Or using it as a digging tool has also been suggested, that it may have been a way to dig out burrows or hook things out of burrows by sticking your foot down with this big fish hook claw.
So like eyes?
Yeah, like an eyes
finger.
Mm-hmm. But on your foot. But then another one that's been suggested by certain studies has been that they may have used it as crampons, the climbing hooks.
Yep.
And used it to climb up a prey animal. And other people I've even heard have suggested that it may have been to climb just stuff.
Yeah.
Like trees and stuff and rocks that you would want a big grippy claw to help you scramble up.
That suggestion, at least from what limited exposure I've had, I feel like I've been hearing it more and more.
Mm-hmm.
That's sort of been, it seems like it's been gaining ground, the notion that the claw may have been a climbing tool.
So, to try to weed out to see if this climbing tool or other versions of hunting or other tools for getting food, to see which one's more viable, they did a digital reconstruction. They reconstructed, from what is known, the muscle and skeleton of the leg and claw. And then they used mathematical models to then test different positions, different flexes of the claw, different positions of the leg, to see how the muscles would interact, to see which positions created the most force on the tip of the claw.
I like paleontological studies that sound like Mythbusters.
Right? That's exactly what it sounds like. And that's basically what they're doing, is they're trying to see, we're just going to put it through a bunch of yoga poses, which one seems to put the most effective force on the claw. What they found was a crouching pose. And so a crouching pose with a flexed knees and ankles, so as if it was about to jump or something, would put the most power behind the claw. But that high point, that high power, is still relatively low.
Interesting.
So even at the most powerful that they could find in their models, it wasn't actually that notable of a powerhouse attack. Which suggests that we can probably rule out a lot of the slashing options, because it probably wouldn't have been very useful to kick out at a thick-hided animal and actually do any damage. So it does not eliminate those, and it does not ensure that it was a climbing tool or a digging tool, but they're leaning away from a slashing weapon and much more of some sort of hook.
Interesting. So it sounds like the way you might describe, like a pickaxe or a hook for climbing, that you could use that as a weapon.
Yeah.
But that's not what it's made to do.
The one that the article kind of settles on, unofficially, leaning toward, is grasping small prey. Because the foot also is good at grasping. The claw is not just a single motion, and the toes are not just straight out. It can actually grab stuff very much like a bird of prey talon. And so it may have just been a very exaggerated eagle claw sort of device, which we see on birds of prey today. Harris hawks and a couple of other hawks, their inner toe claw is larger. That's still a thing in birds of prey today, is to have that inner toe, and it's to lock into prey as they start tearing into it with their beak while the prey is trying to throw them off. So it's like a bucking bronco saddle.
Right.
Strapping yourself in until you can kill the prey on the ground.
And if it's a smaller dinosaur or a little lizard or something that you're just trying to pin down, you don't need a claw that's going to punch through it.
Yep.
You just need a claw that's going to hold it in place.
And even if it was something roughly their size, it's something that might allow them to balance on top of it.
Yeah.
As they're just parrot footing onto this thing's back and chewing away at its neck.
Yeah, well, it brings to mind the Fowler hypothesis,
Yep.
which is which I still love the image.
It's wonderful.
Of the Dromaeosaur. Deinonychus always in my head, because it's the best one.
Correct.
With its feet on an animal, claws in, wings out for stability, leaning in to peck and pull at the flesh.
Because that's the thing that, to me, is almost a shame about dromaeosaurs, is whenever people bring them up, it's almost always straight to the claw. But they have blade-like teeth.
Oh, yeah.
They have awesome teeth. We emphasize that claw, but a bite from one of those would just sever fingers.
They have the same style of teeth as Komodo dragons.
Absolutely.
Yeah. I'm gonna slash a row of teeth across you.
Mm-hmm. They would bite and just remove sections.
Yeah.
And so I feel like it's really easy to forget and overlook that claw doesn't have to be the main weapon. They've got plenty.
And I always love my favorite comparison to dromaeosaurs is modern day cats.
Yes.
Because it's two fast, agile, muscular, relatively small-ish, usually, animals that are made out of knives.
Yep.
And modern day cats are using those claws for climbing and gripping while running and for holding on to prey.
That was one of the comparisons they made in the paper to them perching on the back of a larger predator or a larger prey item, was because of the similarities between the claw and the gripping claws of cats.
Yeah.
And so that comparison has been made for the use of that claw, that it was a grab and hold less than slash.
Yeah, because they're not a cat. To my knowledge, even big cats aren't using their claws to disembowel their prey.
I feel like the idea of cat claws being slashing weapons is purely from people being scratched by house cats.
Yeah, it might be.
Because the cat they're not aiming to cut you. They're just putting claws out and moving it fast toward you.
Right.
Hopefully to get you to go away.
This will hurt you.
Yes. But if you ever watch them catch something, lions or something, they're just grabbing.
They're gripping and holding.
Yeah. They're not swiping at the antelope. They're just locking on and then teeth in and crushing the spinal cord.
So it's dromaeosaurs may have been big cats with wings.
Yeah.
Yeah. Hey, speaking of the feeding habits of things with wings, let's see what I did. My second news item I'm very happy to announce is about pterosaur poop.
Those are both awesome words.
Right? So pterosaurs, for those who need a reminder, since we still haven't done an episode about pterosaurs, it's coming. Don't worry. Hey, if you want to hear it, send us more suggestions. Are the flying reptiles of the Mesozoic.
Yes.
The leathery, winged, sort of fuzzy now, cool, not birds, not dinosaurs, flying reptiles.
The big paraglider reptiles.
And poop can fossilize.
Yes, it can.
Episode 30. This is research by Martin Kvarnström et al. In Peer J, also Peer J, and we'll link to an article by John Tennant in Plus Blogs.
Hey!
We're giving them a lot of traffic this time.
Yeah.
Pterosaurs are fascinating. Super diverse, all over the world. They come in all sorts of shapes and sizes. One of the biggest questions about any animal, of course, is what did they eat?
Mm-hmm.
And with pterosaurs, it's often very mysterious. Most of our understanding of pterosaur diets comes from the obvious starting places. What are their teeth like? What are their jaws like? There are a couple of examples of gut contents.
Ooh.
There's a famous, I think there's a Rhamphorhynchus specimen that has a fish remains in its gut. There's a few of those, so that's handy. But, and I was surprised to learn this, up until now, no remains have ever been identified in pterosaur poop.
Interesting.
This article refers to one known pterosaur coprolite that has inclusions in it, right, stuff inside that's unidentified.
Okay.
Which makes this the first ever study to examine the contents of pterosaur poop.
Wow.
Yes, and we're here for it.
On the front lines.
Here are the front lines. We're number one, or at least number two. In this study, they examined 3 coprolites from late Jurassic Poland, around 160 million years ago, in an area with lots of pterosaur footprints.
Nice.
So the morphology, right, the shape of the coprolite suggests to them pterosaur-sized, pterosaur-shaped, and associated with lots of pterosaur tracks, so likely pterosaur. They did a synchrotron analysis to examine the contents of the poo, and what they found is awesome. It's better than what you're thinking. Inside of the poop, they found lots and lots of very tiny shells and bits of carapace from clam-like things, little crustaceans. They found bristles that may have belonged to polychaete worms.
Ooh.
But most of the coprolite was full of foraminifera.
Wow. Itty bitty.
Which we've talked about in our Spotlight series. Adrian came on and taught us about foraminifera. They are tiny aquatic protists. Microscopic little shelled, little tiny floating organisms. This arrangement of poop contents is very similar, the authors point out, to Chilean flamingos.
Yeah.
Which are filter feeders.
They are.
We talked about flamingos in episode 37.5. They do that ridiculous thing where they put their heads upside down under the water.
Yep.
And they have these bristles in their beak that strain tiny food particles out of the water. So perhaps this poo came from pterosaurs that were living in a similar environment and feeding a similar way. This is the first direct evidence of filter feeding in a pterosaur.
Nice.
It's been suggested for pterosaurs, because there are pterosaurs with really closely spaced teeth and flamingo-like beaks that paleontologists have said, yeah, that might be a filter feeder.
Yep.
Some of which lived in this region.
Hey!
The authors point out the genera Gnathosaurus and Tenechasma, both of which are types of pterosaurs with long beaks and very closely spaced teeth. The coprolite One of the coprolites is also noticeably larger than the other two, which the authors suggest might mean a larger individual. And, intriguingly, the larger coprolite has a higher proportion of forams to, like, crustacean-y bits, which, if the larger coprolite is a larger individual, and if that is representative of their feeding style, might mean that as they got older, they changed how they were feeding.
Interesting.
That the older ones may have been more specialized for filter feeding the tiniest things, which is apparently in line with the fact that Tenachasma, one of those pterosaurs we mentioned, we know their growth series, and they get more teeth as they grow.
Wow.
So we might be seeing here support for the notion that they are changing their feeding habit as they get older.
Wow, that's not at all what I would have expected.
How cool!
Gee, yeah, because my first thought when you said the difference in the droppings was that not that they were feeding differently, but that they had that the bigger one would have had a better feeding spot or something, like a more ideal feeding location. But ontogeny is cooler.
Episode 33.
That's awesome.
And if you like numbers, here's a number that I thought was awesome. The remains, this is a sentence from the paper. I'm paraphrasing, but this is straight out of the paper. The coprolite remains suggest a sieve optimized for catching prey of about 300 micrometers.
Wow.
We can tell the size of food they were eating.
That's so cool.
Pterosaurs are awesome.
That's amazing.
Yep.
Wonderful.
Hey, speaking of amazing, awesome creatures from the Mesozoic, you want to talk about the armored dinosaurs?
Yeah, I do.
Let's do it soon. Armor is a topic we have discussed in the past. There are lizards with armor. We've talked about crocodiles and alligators.
Absolutely.
Having armor. We did an episode about sloths.
Yep.
Episode 24. They had bones in the skin. We've talked a bit about armadillos and armor is a recurring theme.
Turtles.
Turtles. We had episode 60 all about turtles. Very few animals, if any animals, have gone to such an extreme as the Ankylosaurs.
They're kind of the textbook case for fully armored animals.
Maximum armor. Now, if you can't think in your head about what an Ankylosaur is, if you've seen stuff with dinosaurs, you've probably seen them. In Jurassic World, the scene where the kids are in the hamster ball thing, and Indominus is attacking those bony dinosaurs with the tail clubs.
Yep.
Those are Ankylosaurs. Ankylosaurs are quadrupedal, four-legged, herbivorous dinosaurs, mostly on both of those counts, that are just wide-bodied, covered in osteoderms.
Yes.
So we've mentioned osteoderms before. These are bones that grow in the skin.
Absolutely.
They grow separately from the rest of the bone, like the vertebrae, skull, ribs, and stuff.
Yeah, this is what sets turtle armor apart from most other vertebrate armors.
Yes. Crocodiles, the bony armor in the skin. Same thing with skinks and armadillos. Ankylosaurs had bony armor in the skin that came in a whole variety of shapes and sizes.
It's amazing.
And different arrangements in the different ones. You had just little tiny osteoderm bumps. You had big knobs. Many of them had spikes.
Yes, they did.
Sticking out of different parts of them. Some of them had osteoderms all around the neck. Some of them had it oftentimes on the shoulder, down the tail, sometimes on their legs, belly. Some famously had osteoderm coverings on their cheek and eyebrows.
Yeah, they did.
So these animals ranged from being just these fully armored tanks to lighter, less armored, less ornamented creatures.
Yeah, like a armored Jeep versus a Abrams tank.
Yes. But all that they share this armored trait. Also, a bunch of them had tail clubs.
Yeah, they did.
More on that later. A couple of other interesting features that you see across ankylosaurs. They're typically wider than they are tall.
Yeah.
They're very much like turtles in that regard.
Absolutely.
That they are just wide-bodied, low center of gravity. The old image that I remember from all my dinosaur books as a kid was that it always showed Ankylosaurus or one of its relatives being attacked and just laying down.
Yes.
Now I am a bumpy hill, and you can't get to any of my soft parts.
Yep.
They tend to have broad snouts, they have a little beak. In some cases, very mobile jaws.
Interesting.
Which may relate to more specialized feeding habits. More on that later. Ankylosaurs, the whole family, Ankylosauria, were most diverse and most widespread during the Cretaceous period. The last chunk of the Mesozoic era, so between 150 and 65 million years ago.
When all the dinosaurs got ridiculous.
When all the best stuff was in the Cretaceous. With apologies to all the, I don't even know what you're a fan of, whatever. Jurassic stuff, blah. Cretaceous, cool
all
things.
The Allosaurids.
I guess so, yeah. All the Allosaurids. And the Stegosaurids, actually.
Yeah, that's true. Oh,
Stegosaurs were mostly
Jurassic.
like
Stegosaurs.
We'll talk about Stegosaurs in a second.
Yes.
Ankylosaurian dinosaurs generally come in two main groups. On the one hand, you have the nodosaurs.
Yeah.
Nodosaurs include names you may have heard like Sauropelta and Borealopelta.
Yeah.
Pelta, by the way, is one of those, like, dinosaur groups get these trends, these patterns. Pelta is a suffix given often to ankylosaurs, particularly nodosaurs.
So it's like how Suchus pops up all throughout the crocodilians.
And raptor and mimus. Nodosaurs ranged from as tiny as 3 meters long, which is like...
So just a lap ankylosaur.
Yeah, a good-sized alligator that's
Jeez.
10 feet, all the way up to perhaps as much as 7 meters.
Wow.
What is big? That's like 25 feet long.
Wow.
Many of the later nodosaurs, sort of the more derived nodosaurs, had huge muscular shoulders and big spines coming out of the shoulders.
I love it.
I've gotten to see some of these up close, man. They like just these huge spikes.
Yes.
Like feet-long spikes
like
sticking out of the shoulders.
Where the football, American football shoulder pad would be, but just with a giant spike coming off of it.
Yep. I worked with Mike Demick up in Adelphi for a while, helping him prep stuff in his lab, and they had a lot of Sauropelta. And I got to open a jacket with this spine. It must have been 2 or 3 feet long. And just imagining it's at like perfect Deinonychus clotheslining height.
It's like the spikes they would put on the chariot wheels in
Yeah,
like Greek
right.
and Roman times that would just cut soldiers' knees out from under them. It's just that, but for small predators.
And if you're wondering, well, why do you need spikes if you have a tail club? They didn't.
Yeah.
Nodosaurs didn't have tail clubs. That's another group. Nodosaurs are found all throughout the Cretaceous in Europe, North and South America, and Asia. So they're found fairly widespread, mostly in the northern continents, but fairly widespread. The other major group of the Ankylosauria are the Ankylosaurids.
All right.
Which includes Ankylosaurus.
All right.
These are the quintessential Ankylosauria, Ankylosauridae, sometimes Ankylosaurinae, deep down underneath that, and then Ankylosaurus, because this is how taxonomy works.
Just in case you forgot.
Ankylosaurus, the quintessential ankylosaur, latest Cretaceous North America, is one of these. So is Euoplocephalus, another very famous one, and the recently named Zool. Zool, who we described here on the podcast before. More about Zool later. They also have a range of size from those little, itty-bitty tiny 10-foot-long ankylosaurs.
Just pocket-sized.
And then estimates for the largest ones have ranged from 8 to 10 meters.
Wow.
Which, even on the low end, is a 30-foot-long animal.
Wow.
The largest ankylosaurs were rhino-sized creatures, but armored with long tails.
Yeah, exactly. Like it's a rhino with plate mail and a phone pole attached off the back, like
a baseball bat with a mace on the back.
Just a mace scaled up for a Goliath.
Yes. Ankylosauridae, this family, in contrast to the nodosaurs, tend to have shorter skulls, They often had these triangular horns on the back of the skull.
Yeah.
The sort of backward pointing horns. Many of them had very well-developed hyoid bones, which are the bones in your throat that help support the tongue.
Interesting.
Yes, so again, maybe specialized feeding habits.
Means we could get licks from Ankylosaurs.
Perhaps we could.
That's all I care about.
And the Ankylosauridae, the most famous attribute of the group, is that their tails ended in a club.
Boom, a knot.
This rigid tail, and then at the end of it, this bulb of osteoderms that we will talk about at length in a little bit.
Yes.
The Ankylosaurids were present in Asia in the early part of the Cretaceous, but they really hit their stride toward the end. As the late Cretaceous comes in, they become more diverse in Asia and actually start replacing the nodosaurs.
Oh.
So they were a sort of newer version of Ankylosauria that took over from the earlier group. And in the late Cretaceous, Ankylosaurs move over to North America as well.
Woo!
Which is where we get the most famous ones from our neck of the woods.
Nice.
There are other Ankylosaurs. There are some that don't maybe quite fit in either of those groups. There are early examples. Some older papers will also refer to a third group, the Polacanthids, which is based on a species, a genus, a type of Ankylosaur called Polacanthus, which was famous, among other things, for having big shoulder spikes and a shield over its hips.
Ooh, cool.
Like this fused region of osteoderms, which had been called a pelvic shield.
Nice.
But not all paleontologists agree that that's actually a separate group. It might just be a part of the nodosaurs. It might be, that's not necessarily decided upon. But suffice it to say, huge diversity.
Absolutely.
Lots and lots of species all over the world. Really cool.
Very awesome. I've always had a soft spot for nodosaurs. I love Ankylosaurs with their awesome tail clubs, but nodosaurs are just like covered in spikes and blades.
Yeah.
And because they don't have a tail club, they have this like long, more flexible armored tail, which makes them kind of like big herbivorous crocodilians, and I like it.
They always remind me a little bit of pangolins.
They have a very pangolin feel.
Where it's this sort of, they feel smoother.
Yes, sleeker.
In that way. A little bit sleeker, which isn't always the case, but that's sort of the image that I have in my head.
Well, I could picture, I would believe a time-traveling field guide if they told me that a nodosaur could be surprisingly quick on its feet.
Yeah.
They would have to prove it to me if they said an ankylosaur was surprisingly nimble. Like,
yeah, I see what you're saying.
Ankylosaurs have this very rigid feel and look to them because of just the thick turtle-like armor.
Yeah.
Nodosaurs feel like they could still be flexible if they needed to be. I don't know that that's true.
Yeah, none of this is definitive.
No, I don't know that's... But they have a look that they're a little less armored and a little more normal-bodied.
And they may have been using their armor in different ways. More on that later. So that's Ankylosaur diversity at its peak. But let's take a step back. How did Ankylosaurs get started? Where did they come from? The answer is the same place as stegosaurs.
Ooh.
So stegosaurs, which are your plated dinosaurs like Stegosaurus.
Yeah, the ones with the big flat plates on the back.
And Ankylosaurs are both the two major members of a group called Thyreophora.
Yeah.
Thyreophorans get their start way back in the Triassic, but we don't have a lot of fossils from the Triassic into the early Jurassic. So the earliest known ones are kind of a little bit messy. It's always hard to know where the origin of a group is.
Wait, early dinosaur stuff is vague?
Sure is.
What?
The oldest and most sort of basal, earliest example of Thyreophorans are generally sort of considered this is the guy, is Scutellosaurus.
Mm-hmm.
Lived in western North America, was bipedal, like most dinosaur groups started out. In fact, all dinosaurs come from bipedal ancestors, two-legged. Ooh. It was probably a little herbivore, only 1.5 meters, so actually small.
Yeah, that's much more manageable.
And has a bunch of small osteoderms all over its body.
That's adorable.
You move a little bit closer on the family tree, and you get Scelidosaurus, another small armored dinosaur, which is often considered the earliest example we have of an ankylosaur.
Yeah, like definitely an ankylosaur.
Lived in England, quadrupedal, now you're down on all fours, covered in armor and scutes, so the osteoderms are covered in keratinous sheaths, just like crocodiles.
Woo!
This one gets in the 4-meter range. So now we're back to being gator sized.
Yeah.
Right now we're big. And then there's another one named Emalsaurus in Germany, which is very similar. So the early Jurassic, we are seeing the beginnings of the two branches of Thyreophora separating. And by the late Jurassic, we have some proper early ankylosaurs. Things like Mimerapelta and Gargoylosaurus.
I love it.
Both of those are from Western North America, and by that time, they've got, like, heavily ornamented skulls. They've got wide, low-slung bodies. We have ankylosaurians proper.
Yes.
And then it's in the Cretaceous that we get the major diversification of our nodosaurs and our ankylosaurs in all the diversity that we love.
Yeah.
Here are some famous ankylosaurs that you may have heard of.
A little who's who.
A who's who of ankylosauria. We'll start, of course, with the most famous ankylosaur, the quintessential ankylosaur.
Zool!
No,
Oh.
you stop that.
Oh.
There is no Zool. Wait. Ankylosaurus magniventris, named in 1908 by famous American paleontologist Barnum Brown. So that's 3 years after Tyrannosaurus, so we're going way back.
Yeah.
Ankylosaurus is one of the last and largest of the entire Ankylosauria group. Lived at the very end of the Cretaceous, so Ankylosaurus was there for the end Cretaceous extinction, episode 5. And despite being the prime example, it's not really very well known.
Weird.
Only a handful of specimens are known. It's been found in Wyoming, Montana, Alberta, and Saskatchewan. But even where it's found, it's usually very rare. I found a study that cited that in Hell Creek Formation and the Lance Formation and sort of those famous latest Cretaceous fossil sites, Ankylosaurus tends to make up approximately 0.05% of dinosaur remains.
Wow.
Which suggests that it was either very uncommon or that it didn't actually live in those places.
Yeah, and it was visiting.
It was living elsewhere and occasionally wandering in here.
That's so odd because for the rest of the VIP famous dinosaurs like Triceratops and Tyrannosaurus and stuff like that, they're pretty darn well known.
Yeah, well,
Like
a lot of the earlier ones though aren't.
Mm-hmm.
Like some of the others, like you're saying, absolutely are. But it's not uncommon for a dinosaur to lend its name to a group.
Mm-hmm.
Like Spinosaurus
Yes.
is a good example of this, where it's like, yeah, it lent its name to the group, and then we didn't find anything more for decades.
Yeah, and that's very true. This is by no means an uncommon thing. It's just this one stands out because it stands among other. Typically, it's often grouped.
Yeah,
they're always like, yeah, there's Triceratops and Tyrannosaurus and Apatosaurus and then Ankylosaurus, and then now there's one that we actually don't know much about.
Yeah.
Which is very interesting.
It's also notable, and this is also not an unusual case, Ankylosaurus is a weird ankylosaur. Like,
Woo!
it's the famous one, but it's really unusual.
It's like the equivalent to when we have a weird extant
Yes.
descendant of something. Like the one famous one is actually a really bad case study.
Yeah, there's been a lot of papers studying, like, its jaws are kind of different and its skull is kind of different. One of the things that makes it unusual is its size.
Mm-hmm.
Ankylosaurus is way up at the upper end of that size estimate. So, biggest size estimates for Ankylosaur are up in the 8-meter range. This is one of the largest ankylosaurs, on par with the biggest ceratopsians and the biggest stegosaurs. Weight estimates have had it up to maybe 6 to 10 tons. So this is an animal that weighs as much as an elephant. It's just shorter.
Yes. I mean, that's always been a weird thing about ankylosaurs is, now it wouldn't fit lengthwise, but it, especially if it crouched, could stand within a normal room. Like,
yeah.
And like Triceratops could not. Triceratops would be gouging our ceiling out right now. But like Ankylosaurus could, and that's That's weird.
Yeah, well,
For
because
such a
they're
big animal.
strangely shaped.
Yeah, exactly. Like, your proportions you don't fit the normal ratios.
One of the most interesting things about Ankylosaurus, because it's been known so long, is our depiction of it has changed so much. The original depiction of Ankylosaurus by Brown back in 1908 had it just covered, like neck to tail, in these mostly uniform osteoderms.
Yeah.
So, all the same shape, all the same size. It looks like a pineapple. Like all these osteoderms in rows down the back. And that depiction did not have a tail club.
Yeah, just a little armored whippy tail.
Because we didn't know about the tail clubs yet.
I don't want to ever live in a world like that again.
Later depictions lessened and shrank the osteoderms, mostly in comparing them with other ankylosaurians. One of the things that at one point Ankylosaurus was depicted with a pelvic shield.
Nice.
So that band of osteoderms over the pelvis, which is no longer suspected by all to be true. One of the latest reconstructions that's been published by Victoria Arbour and Jordan Mallon in 2017, so fairly recently,
Wow, yeah.
has a very different pattern. I'll put pictures in the blog post. It's got these half rings of osteoderms around the neck.
Ooh.
So it's this sort of, like those bracelets that don't go all the way around.
Yep.
It's like that, two of them over the neck. That is a band of small osteoderms with big studs in it. Rows, 4 or 5 rows of big osteoderms down the body. And then ending, of course, as we know now, in that giant tail club.
It's ridiculously massive.
And when I say giant, the largest known tail club from Ankylosaurus, from the whole tail club apparatus, is 2 meters long, which is roughly 1 will.
Yep.
And the knob at the end of it, and I'll talk more about the apparatus, but the knob at the end is 60 centimeters long, which is 2 feet, 49 centimeters wide, and 19 centimeters high.
Wow.
So it's the size of my cat.
Yeah.
My cat is not 49 centimeters wide, but you get the idea.
No, like this is a medium-sized dog while it's curled up in its bed sleeping.
Yes.
Wow.
Just massive.
Jeez. So this is me sticking off of an animal carrying a couple of bowling balls.
Yes. More on the tail club later. Some other famous ankylosaurs. One of the earliest one known was Hylaeosaurus, named in 1833.
Oh, wow.
Hylaeosaurus, it was found from the early Cretaceous of England. It's a nodosaur, so one of the spiky, no-tail clubby ones. Fairly large, right? We're talking 5 meters sort of thing, 5-6 meters. Average ankylosaur size. Big spikes on the neck and shoulder. Hylaeosaurus is very famous for being one of the 3 animals placed in Richard Owen's original definition of dinosaur.
Cool.
The 2 you always typically hear about are Iguanodon and Megalosaurus.
Mm-hmm.
But the third, the one that completed that trilogy, their Wonder Woman, was Hylaeosaurus, an ankylosaur.
That's awesome.
Yeah, the definition of Dinosauria was those 3 dinosaurs.
That's really cool.
There are a couple of really well-known examples from North America, such as Euoplocephalus, which is a tongue twister of a name. I love it. Euoplocephalus, I think, was one of the first dinosaur names that I learned, like complicated ones that I remember learning and going, I can do it. Named all the way back in 1902, so actually named earlier than Ankylosaurus, and known from a whole bunch of places in North America. Lots of specimens, but a lot of partial specimens.
Okay.
In Canada, it was an ankylosaurid, so tail club and all, and it was a big one. This was almost the size of Ankylosaurus.
Wow.
One of the most famous North American nodosaurs is Sauropelta, which is known from a couple different states. Another one that's rhino-sized, and as I was discussing before, has those huge spikes.
Yeah.
Shoulder spikes, neck spikes, size of a rhino, fully armored. Another really notable ankylosaur is Antarctopelta.
It's a good name.
Can you guess why Antarctopelta is notable? It is one of the only dinosaur specimens ever found in Antarctica.
Yeah.
And that is quite a ways removed from the greater diversity of nodosaurs and ankylosaurs in general. The late Cretaceous, one specimen has been found on James Ross Island, Antarctica. So our clue, and it was named in 2006, so this is a fairly recent discovery.
Yeah, newer one.
And our only clue so far that this group of dinosaurs made it to Antarctica. And then there have been some very famous newer discoveries. In 2017, the world was introduced to not just 2 new species of ankylosaurs.
Nope.
But 2 of the most beautiful dinosaur specimens ever discovered.
Yep.
Both in 2017. It was like that thing where movies come out, where it's like Volcano and Dante's Peak.
Yep.
And Armageddon and Deep Impact came out the same year. Well, Zool and Borealopelta came out the same year. We've talked about both of them on the podcast before. Zool was discovered in 2014 in Montana, named in 2017. It is the most complete ankylosaurid, so like Ankylosaurus, tail club and all, in North America. That specimen, which dates back to about 76 million years ago, has the armor preserved. The soft tissue sheaths over the armor are preserved. Yeah. So you can see the keratin covering on some of the osteoderms. There's even possible evidence of damage to the armor. It was the size of a white rhino.
Yep.
Right? 20 feet long, the weight of the rhino. Its full name is Zool crurivastator. Now, Zool is like Gargoylosaurus.
Yep.
Named for its appearance. It's named for Ghostbusters.
Yeah, the demon dogs from the first movie.
Yeah, the god that Dana is. It's the dog. Yeah, the dog god.
It's the Zool is the one that possesses Dana.
Yep.
And then she becomes one of the demon dogs.
That's right.
So one of those demon dogs was named Zool, and that's
the gatekeeper.
The gatekeeper.
There is no Dana, only Zool.
Yes.
It's funny to me that you have some that are named for being hideous, but then also like Cychania is an ankylosaurian that its name means beautiful.
Because they are.
Because they are. Zool's species epithet, crurivastator, means destroyer of shins.
Which is, I mean, it's probably my favorite dinosaur name.
It's a
Zool,
good one.
the destroyer of shins.
Zool, the destroyer of shins.
I challenge someone to beat that, because I'd love to hear it.
The other super cool ankylosaurian that came out 2017 was Borealopelta markmitchellii. Discovered, this one's a nodosaur.
Yes.
Discovered from the early Cretaceous of Alberta. Again, it's got integument preserved. It's got organic layers. The scales on its skin are visible. Sheaths over its horns. Like, these are the 2 that were in the news, and they look like statues.
It looks artificial when you first see a picture.
Oh, yeah.
It looks like a reconstruction.
Yeah, it looks like somebody sculpted it.
Absolutely. Or like someone put the pieces back together the way we thought it might have died.
Yes.
And that's not what happened.
No, it was just preserved that way.
In the position it died.
Borealopelta reportedly preserves 172 armor plates of various sizes, representing roughly 2/3 of its estimated life covering, and it preserves pigmentation.
Yeah.
So there was the study that came out that showed that it is darker on top and lighter on the bottom, except that its big shoulder spines are lighter in color than the rest of its back, which suggests 2 things. One, that the spines may have been for display, which makes perfect sense, and it was counter-shaded.
Yeah.
Counter-shading is a strategy, and we talked about this when I think it was Psittacosaurus came out, with the coloration of Psittacosaurus. Counter-shading, in short, means you're dark on top, light on bottom, and it helps you go unnoticed in your environment.
Yes. When the shadows are cast on your belly from the light above, you end up being just one kind of blob color.
Breaks up your outline.
Yes.
Which the authors noted was really interesting to see, because this is an animal the size of a rhino, and today you don't see counter-shading in animals larger than like a moose.
Yeah.
Because they don't need it.
Yeah, because predators only get so big nowadays.
Yeah. So this is an animal with camouflage to hide from some really big predators.
Yeah, the Mesozoic was way tougher. Way more intense.
Borealopelta, like I said, pelta. Pelta means shield.
Yes.
And it just is a common suffix for nodosaurs. Borealo is north, I believe. Mark Mitchellii, it's named after the preparator that worked on it.
Which is cool.
Borealopelta reportedly took more than 7,000 hours of prep work. I don't know if Mark Mitchell did all of that.
But if so, earned that species name.
Even if he didn't do all of that. Whew. I have gotten to see Borealopelta.
Yeah.
When I was at SVP in Calgary, I got to go to the Royal Tyrrell. I rode up there with Ann Weil and Mary Schweitzer. Boy, that was a cool trip. And I saw Boreal. It's so pretty. It looks so cool. Go to the Royal Tyrrell Museum.
Just head on over.
up in Drumheller. So those are some famous ankylosaurs. That's the ankylosaur diversity. There are lots and lots of species from lots and lots of places, which brings us to, the other questions. The interesting questions like, how did they live?
Mm-hmm.
How did they die?
Mm-hmm.
What were they doing with all that armor?
Yeah.
More on that in just a bit.
Next episode.
So, we take a trip back to the Cretaceous. We see, in the distance, a moving mountain of spikes and knobs, an ankylosaur. What's it doing?
Being awesome.
Most likely, in addition to being awesome, looking for food.
Yep.
Ankylosaurs are herbivores. At least, mostly, probably, maybe.
All right. I'll take it.
The low build, right? They're low to the ground. They have often this wide beak, generally very tiny teeth, not very specialized teeth. So comparing to like Triceratops and the hadrosaurs, ankylosaurs had tiny, not very specialized teeth. So paleontologists have generally suspected that they were probably feeding on low-growing plants,
All right.
close to the ground, not chewing a whole lot. They're, ferns and shrubs, maybe small fruiting bodies of things, which is a fun thing to imagine that the ankylosaur is eating down on the ground and the ceratopsians a step above and then the hadrosaur is rearing up for the taller things. And then your sauropods, right? You've got this sort of niche partitioning.
Yeah, it's like what they show all the time with the antelopes and giraffes and elephants in Africa. Like eating on the grass, lifting up your head, standing on tiptoes, and then being ridiculous.
Yeah. Of course, as we discussed, there wasn't a ton of grass back then, episode 38. So ankylosaurs would have been eating little shrubs and things. As I mentioned before, some ankylosaurs had these really developed throat bones, hyoid bones, which might suggest that they're using their tongues in an unusual way. So this may have been some sort of specialized feeding habit, like are you eating a particular kind of plant? Maybe even eating insects.
Yeah.
Right? Using a powerful tongue for stripping leaves or grabbing up insects.
I would pay money to have ankylosaurs have giraffe tongues.
Oh, that would be wonderful.
Just this big old dopey ankylosaur walking up and then this just like forearm length tongue coming out and grabbing food.
Well, how else do they clean their face scutes?
Just like a gecko.
Like a gecko. There's also some suggestion that their jaws moved differently than other dinosaurs. So they may have been that their jaw moved farther back while grabbing at stuff. So in some of them at least, the mouths are unusual.
All right.
But exactly what they're doing with it, we're not 100% sure. I mentioned earlier that Ankylosaurus is weird. One of the ways it's weird is that its nostrils are strange. So its nostrils are kind of downward and sideways pointing.
Yes.
Which is unlike most animals, most ankylosaurs, where the nostrils are more forward and not covered. They're called roofed. Ankylosaurus has roofed nostrils.
Interesting.
Because they don't open above, they're pointing more downwards.
Interesting.
And some authors have pointed out that this is similar to the nostril arrangement we see in some digging lizards.
Okay. keeping dirt from getting in your nose.
Others have pointed out that some ankylosaurs seem to have very strong front arms. Now, I don't think anyone is suggesting that ankylosaurs were burrowing.
I am.
Although that's one of the suggestions for what turtles may have evolved their shell for. That's a separate discussion. Episode 60. But that powerful forearms and that sort of getting towards shovel shape to the face may suggest that they were rooting around underground for stuff.
Neat.
Looking for tubers and roots and things like that.
Like truffling. Very much like a boar, just with its not hooves, but with its feet and its snout just plowing into the dirt, looking for the good stuff. Interesting.
And of course, there's such a diversity of ankylosaurs that they were probably doing a number of things.
Yeah, you can probably suggest a feeding habit, and one of them might have been doing some part of that.
But being low to the ground puts you in a good place to be digging around for potato-like things.
Cool.
Of course, very famously, back in 2016, a particular ankylosaur discovery threw a huge wrench into our thoughts about ankylosaurs, and that was Liaoningosaurus from China, which was found fossilized in, I want to say it was a river deposit, but it was a freshwater deposit with a fish in its belly. A fish in its belly.
Yep.
Now, assuming that the authors of that study had their interpretation right, that wasn't like an accident, this appears to be an ankylosaur that ate a fish.
Yeah.
So maybe they were sometimes carnivorous?
And that's something. This is something I love to point out anytime I'm given the chance, is that most animals will be carnivorous if given the chance.
Yep.
There's a very short list of animals that will turn their nose up at meat 100% and won't touch it. Most animals, if you offer a little bit of meat, will usually take, like, you could feed ham to most things that are in the forest around you. Like, if you just take some sandwich deli ham, most things would eat that.
Yeah, that's
They
probably
couldn't
true.
survive off of it necessarily. Like, a deer just eating ham probably wouldn't do great. But there's studies that have documented deer eating carcasses before the predators get there.
Oh, yeah.
Stripping meat off of, like, sides of beef that they left out in front of cameras.
Yeah, yeah.
And there's a really great Cracked video, the old comedy YouTube channel, that is all about when animals betray your expectations. And it has videos of cows eating chicks and ponies eating birds. And it makes complete sense that dinosaurs were doing the same thing, that if you left a small animal near a ceratopsian, it would just clip its head off with its beak.
Maybe.
Or that a ankylosaur that was able to get to a fish, whether it caught the fish or not, we don't know. But if it just found a fish and decided to eat it, yeah, I'd buy that 100%.
Absolutely.
Protein's protein.
So they were eating something.
They were eating stuff. I wonder, and I don't know enough about them to know if there's any evidence for this, but if they have such puny teeth, and it would make sense with what we found with other dinosaurs, if they also had a gizzard-like thing going on, just pounding and grinding up vegetation.
If I remember correctly, I read that it was suggested that they probably were fermenting food.
Oh, like a cow.
In their belly, like a cow. Also, sauropods are thought to have done that. So, yeah, they would have had this whole belly machinery going on.
Which also fits with being shaped like a dome.
Yep.
Lots of room for lots of belly.
Lots of space for all that bacteria to go to work.
Oh, man. Ankylosaurs would have the worst farts.
Ooh, yeah. It wouldn't be great.
It's just burping and farting on you like cows do.
Yeah.
Ooh, gross. I like it.
So their noses. Ankylosaurs, the advanced sort of later ankylosaurs, had weird noses. This is something that's been noted about ankylosaurs for a long time, that when you scan their skulls, they have these really complicated looping nasal passages.
Yeah, it's this chamber system.
This has been studied. In fact, we talked about it in episode 52.
Yeah, we did.
A study back in 2018 simulated how the air would flow through these nasal passages to try to figure out what they were for. Because some people had said, well, maybe they were for making sound, a resonating chamber like, hadrosaurs are thought to have done, which we also discussed in episode 52 because it was bioacoustics in the fossil record. But this study, do you remember what this study found, Will?
Yes, I do.
Go on.
Is that it also was highly effective as a cooling system, which is awesome.
that as the air traveled through the passage, it would cool down.
Mm-hmm.
And so it was air conditioning for the brain.
Yeah, which is super useful if you're in really hot places.
Yep. And also, if you're just a big animal that's
Yes.
going to overheat, and if your head is covered in armor
Very
and
true.
scutes and scales. Now, a similar thing is seen in sauropods and hadrosaurs, so it's not just that you're armored, but that probably doesn't help a lot.
Well, and the thing that is cool to me with this, there's two halves of it. One is that usually when you see big nostrils for cooling off, it's often in running animals. Like nowadays, like a lot of the mammals you see big nostrils on. Like
That's
cheetahs
true.
have a big nose for a cat, and horses have giant nostrils, and a lot of antelopes have big nostrils to cool down the brain while you're running at top speed. So it's cool that the same device might help something that's just big and hot.
Yeah.
But also, it could do both. Like, that's the other thing I always love is there's no reason it couldn't have dual purpose of it keeps me cool, and then I can also bugle through it.
Oh, yeah. Well, and it also, I would suspect that a big nostril in running animals is also helping to gather lots of air
aerate,
real quick.
Like the vent on a car.
Yeah, and it's just... Whereas on the dinosaurs, their nostrils could be small. You're still doing the cooling thing, but you're not getting a blast of air because you don't need it.
Exactly.
Especially because they had that efficient bird breathing system.
Yep, better than ours.
Yes, it is. One of the most interesting things to me about ankylosaurs is their consistent trends in taphonomy. We've mentioned taphonomy before. That is the study of what happens to animals when they die and become fossilized.
Yes.
Animals, plants, whatever. Two trends that I'll point out with ankylosaurs. One is that ankylosaurs are almost always found solo.
Yeah, not in a group.
Rarely in assemblages. Some have been found in groups at younger ages. But adults are almost always found one at a time, which suggests that at least adult ankylosaurs were probably solitary, and they weren't herding like the ceratopsians and the hadrosaurs are thought to have done.
Interesting.
So they would be like the whatever animal on the savannah isn't herding.
I mean, very, very rhino-esque. I mean,
Oh,
we've been comparing it in size of that, but yeah, actually, very rhino-esque.
Very
Rhinos
much like a rhino.
tend to only hang out when it's time to make more rhinos.
The other super cool trend in ankylosaur taphonomy, and we have talked about this before
Yes, we have.
in both episodes 30 and 17. 17 when it was an abstracted SVP, and 30 when it was published. Ankylosaurs tend to be found upside down.
Yeah, they turn turtle.
There was a study, so this was a 2017 study that looked at around 36 ankylosaur specimens from around Alberta that had been found relatively complete, and found that more than 2/3 of them were preserved upside down on their backs. For those who haven't listened to those episodes or need a refresher, here's what the study did. They aimed to ask why.
Yes.
What are you doing?
Why are you rolling over before you die?
With-
or after you die?
3 hypotheses. 1, that it was because of scavenging.
Yes.
2, that it's because they bloat and flip over on land.
Mm-hmm.
Or 3, that they get in water and bloat and flip over.
Yes.
The quick rundown, they didn't find evidence of scavenging on any except one of the specimens they looked at. So probably not carnivores. Also, we don't see it with other dinosaurs.
Yep.
2, they had a bunch of people, a couple of people, I think it was, a couple of colleagues, survey armadillos who are allegedly reported to bloat and then flip over on their backs when they die.
Yeah.
But turns out they don't.
Yeah.
And 3, they made a computer simulation of ankylosaur bodies and floated them in water and found that because of the shape of their body, when they bloat up with all those death gases, they flip over.
Yeah, it's an ankylosaur death simulator.
They flip over, they become unstable and flip over. Then as the gas releases, they sink on their back down to the bottom. The study even points out that their thick skin might hold the gas in longer,
Mm-hmm.
which means they're more likely to bloat and flip and sink.
Yeah, they are more likely to reach that bloating phase because that stuff doesn't burst as quickly. Gross.
So we've got it's what a cool trend to see in a group of animals.
Yeah. I love the idea of, and this is something we see in some other big dinosaurs as well, but the young ankylosaurs might have been grouping together.
Yeah.
That suggestion is awesome. I also need to know what the name for a group of ankylosaurs would be. I suggest phalanx.
Nice.
Or battalion. I don't know which one I like better, but I need this to be discussed.
A fleet. The first thing that came to my mind was rumble, which I think actually is what they call rhinos.
I think it is.
It's a rumble of rhinos.
Yeah.
Dear listeners, what would you call a group of ankylosaurs?
I need to know so I can sleep at night.
A fortress.
A fortification of rhinos.
Of
ankylosaurs. A fortification.
Fortification of ankylosaurs.
That is my headcanon until someone offers something better.
Dear Baskin Coyle, let us know what you think a group of ankylosaurs should be called. There might actually be already a thing for it.
I so hope there is.
I will ask Victoria Arbor on Twitter.
Group names for animals. This side is one of the nerdiest things scientists do.
Oh, I love it.
Because it is almost, in all examples, completely pointless. Like,
oh yeah,
there's nothing more efficient in me saying a basque of alligators and just a group of alligators.
No.
But
it's fun.
Every animal has it, and there's people who argue about what it should be.
So, we've talked about ankylosaur diversity and ecology, but we have yet to touch on the part that you have to touch on. The armor.
The armor.
So what were they doing with this armor? What's the whole deal?
Fighting crime.
Fighting crime.
They are Ironsaur.
They are the battalion. A reminder, ankylosaurs are generally covered in small armor. Ankylosaurians, the whole group. Small osteoderms, right? Little bony patches that tend to cover the back, the tail, sometimes the neck, the legs. Plus larger knobs. Sometimes spikes coming off the neck or the sides or the shoulders, plates down the tail. Some of them have those rings on the neck. Some of them have shields on their pelvis. They come in all sorts of different arrangements. Now, we keep calling them armor.
Yeah.
Which brings to mind the notion of defense.
Yep.
But even in us, armor can have other purposes.
Yep.
Such as display. The armor could be ornamental. It could also be related to thermoregulation.
Absolutely. That's a huge part of it for crocodilians.
Yeah. It's also suggested for stegosaurs.
Absolutely.
They're big plates that that is a solar panel.
Yes.
Or an area for you to release excess heat.
Like a radiator.
Yes. That if you're concentrating vasculature in there, you can control the heat flow. And this is one of those things that's still a lot of debate because in all honesty, it's probably all the above.
Absolutely. Like, in most cases with complex, important features on an animal, it doesn't just do one thing.
No.
Like, you can, antlers are one of my favorite examples where, like, watching a deer or an elk use its antlers for something weird.
Yeah.
Like, I can't remember if it was a reindeer, if I remember right, that was scratching its butt with its antlers. It was leaning its head back and scratching.
That's what I would do with them.
And I love that. I love that it's like, well, yeah, this is meant to fight all those dude bros over there, but also I got an itch. Of course it probably is doing multiple things.
Well, in crocodilians, it's handy for not getting bitten by your friends.
Yep.
But also, if it's my own personal radiator.
It's my big solar panel on my back for blood vessels.
That works too. I did find one study that looked into potential differences between different types of armor. So this was a 2010 study that looked at the histology of ankylosaur armor. So that is the bone growth patterns. Apparently, all across Ankylosauria, the osteoderms are full of collagen fibers in an abundance that you don't see in other dinosaurs.
Interesting.
Unique armor shape to the Ankylosaur family tree. And different groups of ankylosaurs have different arrangements of these fibers, which means that it is potentially an option to identify what group of ankylosaur you have just with a piece of osteoderm.
The different arrangement determined the note it played when you hit each one.
Exactly. Very famously, that is how hunters in the Cretaceous period used to identify ankylosaurs. So they'd walk up and tink, tink, tink. No. You don't want to fight this one.
This one's not right.
The study also found... That's not true. Don't listen to any of that. That's all made up. Sometimes I worry. The study also described that the small osteoderms, the ones that sort of coat the armor area in general, tend to have thin outer bone and thick inner spongy cancellous bone.
Huh.
So your bones, most bones, have two sections, the cancellous bone and the cortical bone. The cortical is the outer wall, the cancellous is the spongy interior that has all the bone marrow and stuff
it's
in
the
it.
walls of a building and the struts inside.
The fact that the armor on these dinosaurs was thin on the wall but thick with the fibrous and cancellous part means, according to these authors, that it would function as efficient, lightweight armor.
Huh.
Sturdy, but not heavy with thick wall bone.
Interesting. It's like carbon fiber stuff.
Yeah.
Interesting. Not made out of it, but like the same concept.
They also found that the larger osteoderms, so the larger osteoderms in general are thought to just be evolutionary upgrades from the smaller ones.
Yes.
They get bigger and bigger, and now you have knobs and spikes. Larger osteoderms tend to have the same pattern. Thin walls with thicker cancellous on the inside, which would suggest potentially that they weren't necessarily super sturdy in terms of being weaponry.
Yeah.
Armor, perhaps, maybe not weaponry, maybe more for display, maybe more for deterrence, especially since nodosaurs don't follow that pattern.
Yes! I'm so glad you just said that.
They found that the spikes of nodosaurs had particularly thick layers of outer bone.
Yeah.
Compared to other ankylosaurs, other members of the Ankylosauridae, and then, outside of those two groups, which suggests that nodosaur spikes were potentially thicker and heavier and sturdier than in other members of the group.
Yes.
So maybe those were weapons.
Because they're the samurais of the Ankylosaurs.
The way that I love picturing a nodosaur with its 2 foot long or whatever spikes, its sauropelta, staring down a predator, and then it charges forward and it does the anime thing where there's just a slash across the screen, and then the theropod crumples to the ground.
The camera focuses on the drop of blood off the
Yes,
blade.
right.
It's so cool.
So there may have been different uses for different armor in different ankylosaurs.
Which makes so much sense. If you're going
Of course.
hog wild with armor, of course you're going to see all the options. I'm going to have armor that is just defensive. I'm going to have armor that's just display in spots. I'm going to have armor that can hurt you while it defends me.
Oh, yeah.
That makes complete sense because these dinosaurs were all about specializing armor.
Yep. Now, who they were using those weapons against is an open question.
Yeah.
Was it for predators? Was it for competition with other members of your group?
Oh, can you picture Nodosaur jousting like the tortoises that charge each other with that special plastron spike they have?
Yep.
Just them fencing and
Wham.
tackling one another.
Oh, yeah. So they may very well have had really complex displays.
Mm-hmm.
Maybe even courtship or territorial disputes. Who knows? Which brings us to the end, not just of the discussion, but of the dinosaur. Before we wrap up, we'll talk about tail clubs. Woo! Ankylosaur tail clubs are weird in that they exist.
Yep.
Tail weapons are really rare in animals.
Yeah, I want everyone to think of their top 3 favorite tail clubs.
Yeah, right? It is rare for an animal to use its tail as a weapon in general.
No, you don't see it often, and usually it's just kind of to deter.
Right.
Like iguanas and monitors.
Yep.
It might cut you, but it's not going to kill you.
No, it's just a smack.
Yeah, it's just,
Get out of here.
Hopefully this hurts enough for you to stop bothering me.
Most animals are using their heads or their arms. Some lizards do lash with their tails, like you mentioned. Some animals have developed spikes on the tail. It's real rare. A bunch of lizards have done it.
Lizards once again.
Stegosaurs, and there are some sauropods that did it as well.
Yeah, they have a almost flail-like thing going on.
Clubs are known in myolaniid turtles, an extinct group of turtles, a handful of sauropods, and glyptodonts, which are the big armadillo Volkswagen things from the Pleistocene.
And actually probably have my favorites club tails, because theirs looks like a morning star.
They're real cool.
It's ridiculous.
But ankylosaurs are next to glyptodons for just the most ridiculous extreme tail weaponry.
Yes.
It is suspected that the evolution of these tail weapons probably went from lashing with the tail to stiffened or spiky tails to weaponry.
Mm-hmm.
Let's zoom in on the tail. The tail club of an ankylosaurid has two parts, the handle and the knob, which are made differently.
Yes.
The handle is picture holding a club.
Yeah, like when we keep comparing it to maces and stuff, it literally has the parts of a mace.
Yeah. So imagine Mjolnir.
Mm-hmm.
It has a handle for swinging, and it has a head, a knob for hitting. The handle of the tail of ankylosaurids has these interlocking vertebrae.
Yeah.
With these long processes that stick off of them and overlap each other so that you just get this rod of bone. That's formed from the internal skeleton.
Yes.
The knob is made of giant osteoderms that surround the end of the tail, which is dermal bone.
Yeah.
Osteoderm bone. So two different types of bone coming together to make this weapon.
When our powers combine, you make a tail club.
But tail clubs are only actually there, for the most part, within the last 20 million years of the Cretaceous. Most of the time that Ankylosauria existed, there weren't tail clubs. It's a much later addition. And what's real interesting is that the fossil record seems to suggest that the tail club evolved in pieces. Handles are recognized in ankylosaurs all the way back to the early Cretaceous.
Wow.
By perhaps as early as 120, 125 million years ago, because we have animals like Liaoningsaurus from China, which is about that age, Gobisaurus, which is also China, which is closer to 90 million years ago, are both examples of ankylosaurs with handles, but no known knobs.
Literally a baseball bat.
The tail has that stiffened interlocking vertebrae, which you can still imagine being a weapon.
Oh, yes.
That's still...
If I hit you with my cane, it still hurts.
Yeah, that's the, what are the things that the police officers carry?
Oh, the batons.
The baton,
Yeah.
a nightstick?
Yes.
Whereas clubs don't seem to show up until around 80 million years ago, and only in Asia and North America.
Huh.
Because that's where the ankylosaurids were.
Yes.
Some of the earliest dinosaurs with tail clubs include Pinacosaurus in China and Talarurus in Mongolia, both around 80 million years ago, which seems to be the earliest evidence, which suggests that for many millions of years, ankylosaurids had bats on their tails, and it was only more recent that they developed clubs. And the knobs get larger over time.
Woo!
The earliest tail knobs, those Mongolian dinosaurs right around 80 million years ago or so, the largest ones are about 140, 150 millimeters. So 15 centimeters, so half a foot.
Yeah.
Which ain't nothing.
No, I mean, that's a good size, cantaloupe.
Yeah, that just whoop.
Yep.
But by the end, you have those ankylosaurs with 600 millimeter wide or long tail clubs. 2 foot from front to back. So tail clubs got more and more, the whole apparatus got more and more developed as time went on.
It's a good thing they went extinct, because they wouldn't be able to walk around nowadays.
Well, see, what I was going to say that, one of the recurring themes that every time I think about the end Cretaceous strikes me is that at Dynasty, they weren't done.
No.
What would have been next?
It would have been a tail club with a little ankylosaur attached that just rolls around.
Now, that actually does bring me to the question of, and again, this is going to sound like a weird question, what was the tail club for?
Yes.
Because again, it seems obvious that it's a weapon and there's evidence to support it. Are you fighting with your own group? Is it for predators? Is it a display feature?
Yeah.
Because, as we've seen, sometimes display features get real wacky.
I could so completely picture it as a display feature for power displays, like gorillas drumming on trees and throwing logs, and gators jaw slapping when they hit the top of the water. can you picture that just pounding the ground?
Oh, yeah.
You know, and just making a, look how strong I am.
Well, hold that thought, because I'm going to tell you that that's wrong.
Cool.
Yeah, at least that specific thing you just said. One of the other suggestions, by the way, earlier on was that the tail may have functioned as a false head.
Oh, yeah.
To distract predators.
Like the fat-tailed skinks.
Yep. I don't know how accepted that is. I've never heard that seriously discussed.
I don't know how I don't even know how you would test for that.
No, and the one paper that mentioned it said that.
Yeah.
It said that. How would you test that?
Yep. Because there's animals that we see today where that's suggested, but I don't know that there's actually hard evidence. Like, I don't know that we have many instances of watching a predator attack the wrong end of a fat-tailed skink.
No, and you'd have to, like, statistically, how often does the bird attack the...
I don't know that we actually have hard evidence for false head stuff. It makes sense, but
So let's talk about the anatomy of the club. In addition to handle and knob, ankylosaurids tend to have huge muscle scars on the pelvis and on the tail, which suggests that they had very powerful tail movement ability.
It was functional, not just looking cool.
The osteoderms of the knob are similar to what I was describing before, mostly cancellous bone, and comparatively thin-walled.
Huh.
Which means that they would have less inertia when moving, but would be easier to swing.
Interesting. They were flotation devices.
Maybe they were flotation devices. No, probably not. Well, that's why they flipped.
Yes.
There you go.
It's please activate your tail club and so that search and rescue can find you. That's so weird.
Now, that doesn't necessarily mean they weren't weapons.
No, like, that still would hurt. It's still bone.
You're sacrificing density for mobility.
But yeah, we've gone from a baseball bat to really hard wiffle bat, which is not what I would have expected.
On the other hand, the tails have sacrificed mobility for stability. The rigid tail, it would actually be more of a powerful swing if the tail was flexible.
Yeah.
But instead the tail is very rigid, which might be just for holding the knob up, elevated off the ground, or for shock absorption.
Oh, okay. Yeah.
That when you're swinging and hitting, you want a rigid tail that's going to take the brunt of that force.
So that you don't sprain your flexible tail.
Some knobs are blunt, and some knobs, at least on the osteoderms, have keels, which is to say ridges. And remember that the knobs would have been covered in a keratin sheath.
Yes.
Which may also have sometimes been keeled. So now you're starting to build an axe. Like, now that you've got ridges on it, which again is really hard to say, okay, is that just for display? Because that would also hurt a lot.
Oh, yes.
Because now you're concentrating the force.
Well, now it's like the shell of a snapping turtle.
Yes.
You have these spikes and these blades that underneath in the bone would not be nearly as sharp.
So there's this complicated anatomy in there that seems that there's a lot of structural consideration. Another intriguing note, the evidence seems to suggest that ankylosaurids are not born with tail clubs. They develop as they grow.
Which makes sense.
In at least some species, the juveniles don't have them.
Oh, cool.
Which might mean that tail clubs are an adult feature, which totally fits with something being display.
Yep.
But also kind of fits with what we said before, where if the juveniles are gathering in groups for protection, once you reach adulthood and you're solitary, now you have a weapon.
Well, and if you're little, you can hide. If you're the size of a Volkswagen, which I don't know why that's always the comedic thing to compare big things to.
At one point, Volkswagens were a big deal.
But if you're the size of a sedan,
of a rhino,
then you can't really hide as much, even with your fancy counter shading.
Victoria Arbour published a paper in 2009 that modeled the tail's use as a weapon to see.
Nice.
She looked at Dioplosaurus and Euoplocephalus and, reconstructed the tails and tried to get a sense of, all right, how much movement could you actually get? What kind of force could you do? She found that the tails have very little ability to move up and down.
Which makes perfect sense.
And it means that what you were saying before with, like, the tail slapping on the ground, probably not the case.
Yes.
That doesn't rule out, like, banging on trees.
Oh, yeah, exactly.
But while they were up and down limited, This paper concluded that they could probably swing horizontally through a good 100 degrees
Wow.
of movement.
That's
So
pretty.
a swing. The study also concluded that while smaller knobs would not reach the kind of force you would need to actually damage bone, the bigger ones could.
Interesting.
That a swing from a full-grown Ankylosaurus tail club would be enough to shatter bone.
Cool.
Now, the paper also makes note that this simulation, this calculation, is only really looking at the tail motion.
Mm-hmm.
It's not factoring in movement of the legs or hips.
Yeah, that's what I was going to say. You got to lean into it.
Probably underestimated. You got to follow through.
Yep.
Is he following through?
Swing away.
Ooh, he's trying. So, at least some of them, maybe even more than we think, would have potentially been actually potent weapons.
Which, even just at their size, for most moderately sized predators, it would make complete sense that that would be a deterrent. Going up against T-Rex, I could see there being more debate, but like a small grizzly bear sized predator.
Oh yeah.
That's something scary regardless, even if it's just bruising your ribs.
Yup. Now again, if it was a predator defense, that's a really weird predator defense.
Mm-hmm.
It's really weird for a predator to come up to you and for you to turn away from it and stick your butt at it and swing your tail around.
Well, and the question that immediately comes to my mind, because they always animate or choreograph them in movies facing sideways to it.
Yep.
Looking over a shoulder.
Over their shoulder.
Looking over their shoulder and then having the tail ready to then whip the hips and tail around when the predator comes in. Which makes me ask the question, could they look over their shoulder?
Yeah, I was just thinking the same thing.
How maneuverable is that neck? Where the placement of the eyes, would they just be able to pop an eye back like a cow and just look back there without turning the head? Like, could an ankylosaur see its tail?
It's a weird position to put yourself in.
Mm-hmm.
So on the other hand, that makes a lot of that evidence makes competition and display look very promising.
Mm-hmm.
But I read an interview with Victoria Arbour where she makes the point that there is very little, if any, evidence of damage on ankylosaurs.
Yeah.
That if they were fighting each other with their clubs,
they were bashing each other.
We have not seen any evidence of that. Now, I also don't think there's any predators that have been found with something that looks like it was you got your legs kicked out from under you.
With a tail club shaped dent.
Yes, right.
And a thigh bone. Because that was my first thought earlier in the episode of when we were talking about the tail clubs being a unique feature of them is, have we ever been able to confirm in any way that an injury to a predator was due to running foul of an ankylosaur?
To my knowledge, no.
And so it's a weird thing because it's also one of those where if it does shatter your bone and then you die shortly later because it shattered your bone, would we be able to tell?
Right.
Like, how do we tell that apart from you falling off a cliff?
And I mentioned before that I think it was Zool that has maybe damaged armor,
Mm-hmm.
but there are ankylosaurs with armor damage that's pathologic. That's disease or
I got
something
an infection
breaking it down. So we have all this really cool evidence for the structure and development of the tail clubs in ankylosaurids, but we don't have any evidence of them ever hitting anything.
It's just the dinosaur version of like souping your car up and never taking it to a racetrack.
They just walked across the forest being obnoxiously loud.
Yeah. They just were trying to pick fights with everyone.
Just banging it on the
Yeah.
trees. It was like the mufflers that people put on their... Yeah, they're like the whistles.
Yes.
And all the hadrosaurs rolled their eyes and the ankylosaur came down the road.
Everybody get out of my way! You don't want to get hit by this! Yeah.
So, ankylosaurs.
Such weird, awesome dinosaurs.
The armored dinosaurs.
Like, they've gone, the reason they stand out, for me, is they've gone to the extreme on basically every feature. Like, almost every physical feature they have, they went to the slider bar in the character creator at Skyrim and just took it all the way up or all the way down, and they did not stop in the middle on any of them.
They are and I'm going to see if I use the lingo of our time properly, very extra.
Yeah.
Young listeners, let us know if we're old.
You're welcome.
Did you understand that part?
There you go.
Speaking your language.
We're bringing you into it.
There was a review, I think it was one of our iTunes reviews, that said that they like that the podcast is full of dad jokes.
Yep.
And I was like, what do you mean? Oh, yeah.
Yep.
Yeah. No, you're not wrong.
We own it.
I hope you enjoyed this episode. I hope you enjoyed this introduction to Ankylosaurs. As always, lots of photos, lots of links in the blog. Check it out. They're so cool. They're so beautiful. Endless forms, most dazzling and spectacular. Before we go, remember we mentioned Patreon.
Yeah, we did.
Another thing that you can do on Patreon if you're above a certain level is you can send us questions for us to answer on the podcast. And we have one.
Ooh.
This is a question that we will wrap up the episode with from Finley, who asks, what are your favorite / the most interesting controversies in the community? Things that scientists vehemently can't agree on.
Good question.
Yeah, it's fun. Not as many as you would think.
Yeah. Like, there's most of the examples that immediately come to mind for me are past controversies.
Yes.
Like, what was the narwhal's tusk used for?
Right.
Now we actually have some pretty good data on it, and we finally have video evidence of them catching fish with it. So, like, now we don't have a debate there as much, but we used to.
Even then, most debates are actually pretty cordial.
Yeah.
Because everyone's generally on the same page that it's like, well, we would know the answer if we had more evidence.
Yeah, like, the only reason we're talking about this is because we don't know.
Right.
It's not that we all have perfect evidence. It's that we don't have the evidence, and we're all just on slightly different sides as to which bits of evidence we prefer.
And often, when you do get, like, actual vicious debates, often, not always, it's because the people involved are kind of jerks.
As I say, it's not the subject matter, it's the debaters.
Like episode 58, the Bone Wars and all that stuff, like, that only happened because those guys were maniacs.
Yeah.
That being said, there are some, like, heated debates.
Absolutely. Or where people have a very strong opinion.
Yep.
On one side or the other.
I think my favorite genre of this is debates over the origins of groups.
Yeah.
So we talked in episode 3 about snake origins and episode 60 about turtle origins, where it's, we really are missing a lot of information, but there's good enough evidence in a couple of different directions that you get people who are, like, actually passionate about it.
Yeah.
And you'll bring up, like, oh yeah, this new study suggests that snakes were aquatic, and you'll have people who will scoff.
Yeah, like,
oh, yo, that again.
Yeah, we have to go through this again. It's tired subjects for these people.
Yes, well, and it's funny because a few, like, the birds origins was one of those for a long time. That there were major disagreements about where do birds fit in the big phylogeny of reptiles. Nowadays, we have a really, really good idea.
Yes.
But I like that that's always... And someday we'll figure out snakes and we'll figure out turtles, and then bats will be the big...
Absolutely.
It'll still be... We'll have it all figured out, and the pterosaur and bat people will still be like, gosh darn it, give us some fossils.
Yep. It's the origins and ends of things.
Yeah.
How did it start? Why did it end? Are often debate points of why did these go extinct? You know, what caused this extinction? Volcanoes, asteroid, volcanoes, asteroid. Well, yeah, but which one's more? Volcanoes or asteroid?
And the most heated debates on that regard tend to be the ones that involve us.
Yes.
Like, no extinction is debated anywhere near as heatedly as the end Pleistocene.
Absolutely. That one is legitimately a heated debate. Like,
oh yeah, I have seen heated debates about that.
You could actually spark arguments.
Oh yeah.
If you bring it up in the right room.
I was at a conference many years ago. I think this was AMQA many years ago, where they were having a big panel discussion about evidence for meteorite impact at the Younger Dryas. So, this significant local climatic event in the northern hemisphere toward the end of the Pleistocene This one group of people was suggesting there was an impact event, and most of the other people, it seemed, were like, no, we don't really buy the evidence. And it was funny because they had kind of set up this panel, like, we're going to have this debate. And one side had come in ready for a fight, but the other side was much more like being sort of calm and not doing that. And the fighting side went first.
Oh, no.
So I remember that this guy gave this presentation where he was like jabbing at the others. And it wasn't like over the top, but it was very much like, hey, gonna take jabs at the other side, gonna make some jokes at their expense. Like, I'm on the offensive. And then the other side went up and just gave a standard presentation, which made the first side look like a total jerk.
Yep. Which is why you don't see these debates too often. Because it's hard not to be a jerk.
Yeah.
Like, if you get heated in a scientific debate, you're flirting with jerk territory.
Yeah.
Pretty quickly. Because that's not the point of science. It's not, like, you shouldn't make scientific advancements via arguing.
Right.
That's not how it's supposed to work. So if that is what ends up happening, then you're doing it wrong.
So there are some things that scientists just have not managed to agree upon, or things that they used to not be able to agree upon and have figured out.
I think one of my favorites, that, like, I don't know what the cutting edge answer currently is, but from the things I've heard, it seems like it is leaning one way, but the origin of flight in birds, of the ground up or the tree down, were they running and jumping or gliding down from trees, was one of those of what people, like, you could bring that up and people would be like, don't mention tree down. I'm sick and tired of hearing it. I don't want to talk. Like, people would get really, and from what I've seen with most, like, a lot of the research, it seems like the ground up has gotten a lot of support recently.
That's my impression.
But I don't know if there's still a staunch tree down.
I do not know.
Contingent. So yeah.
So there's that. I would say those are I can think of some others, but those are my favorites. Those are the ones I can think of that won't spark arguments by saying them on the podcast.
Yes, right. Those are the ones that I'm most intrigued by.
Those are my favorites.
Absolutely. The in-Pleistocene is probably my favorite because it almost is, for every piece of evidence one way, there is a piece of evidence the other way. So it's the most justifiable heated debate.
Yeah.
In my limited knowledge, but it is the one that, no, I actually can understand why there's still a divide, because you both seem right.
And it's a complicated event.
Yes, it is.
Thanks, Finley, for that question.
Yeah, that was fun.
Thanks to Mark, Josh, and Jonathan for requesting this episode. Thanks to everyone who supports us on Patreon. To everyone who came and said hi to us at DragonCon.
Thank you.
To everyone who listens to the podcast and leaves us reviews and tells their friends and reads the blog and all of the stuff.
All of it.
As I said, there will be links and pictures and more notes on the blog post. Check that out in the episode description. Also, our Zazzle store is in the episode description. You can check that out. Or maybe it isn't anymore. It's on the blog. I don't know. I may have taken it off. Go to our store, buy merch. Keep an eye out for recordings from DragonCon. Spooky coming up in October. We release new episodes every fortnight.
All of them.
If there is a topic you'd like to hear us discuss, if there is a question or a comment you have, please let us know. Reach out to us in all the usual ways. And I think that's it. I don't have a dad joke to finish the episode.
Nope.
Sign off phrase.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.